Okay, everybody got a nice picture up in front of you? Okay, so what I would thinking about doing is talking about crud and rust. And so it's a little bit short on when I'm doing this meeting. I should have needed to do this about 2 months before right now because everything is a duck soup out there with a lot of rain. But
You're not in
there,
display mode at the moment.
I'm not.
We're seeing the first page and then the next page after.
Hmm.
Not horrible. I'm just
Yeah, okay, thank you. Huh. I don't see a setting that's going to give me, well, can we just go this way and then I'll figure out how because I have to say, this is a whole new implementation on a start from scratch Windows 11 install. So there are still things that
Hey,
aren't
Mike,
quite right. Yeah. Mhm.
bet it's the
isn't
icon.
up there on the upper left, you got a little white box that says swap presenter and something or another?
Yeah.
Try that.
Okay. Did that make a
There we go.
difference?
Yep.
Okay, there. Now I got something off on my other screen here. Thank you.
28
Um,
years of HP, I remembered something.
Yeah, I'm glad we brought you along.
Okay, but I'm out of good ideas, like I said earlier.
Okay,
Keep
well
going.
you got it. I just couldn't see that for the fuzz up there.
Okay.
That's what happens when you try thinking under pressure. Everything falls apart. So um so kind of the topics we're going to go for is now is a good time, and I should say should be saying about 2 months ago it should have been a good time to think about, taking down your antennas, getting in there and taking a look to see if there's any preventive maintenance that you need to do on your antenna system and get it all cleaned up and ready for the winter. Because once winter sets in, it gets really hard to deal with stuff. I have a friend that brought down last 2 weeks ago. He brought down his tower because his rotator jammed up on him, and so in between shower storms, he managed to get the rotator out of that, and then he has that apart on his workbench and trying to figure out what's going on with that. But once he figures that out, then he's going to have to wait for a break in the rain to get everything put back together out there and get that thing back up in the air. So timing is everything. So this includes, but is not limited to, beams, verticals, wire, balance, mobile antennas, coax, rotators, towers, any kind of grounding system, and blah, blah, the list goes on. So this is just a kind of a generalization program that will kind of go through about things you want to think about as far as cleaning up um, your connections and how things are connect together, and looking for problems that you might need to address. So products used to clean, we're going to talk about some of the products used to clean and mitigate some of the oxidation. Rust is nothing more than just some form of oxidation. It can be aluminum oxidation, copper oxidation, or steel oxidation, but that's what rust is all about. And rust, when that comes about, it gives you a bad electrical connection, which is not what we like. Okay, what do you do with hardware that is rusted to a dark brown color? So we'll talk about how to get in and clean up some really filthy stuff. So we all know that RF travels on the skin of wire. So it's something that it doesn't travel down inside. It's always traveling on the very outer side of it. So that also includes aluminum and aluminum elements. Almost everything in the nature corrodes. So I say almost everything. There are a couple elements out there that do not corrode. And I had a guy that I was having problems with my SIM card, or actually I was wanting to, they wanted to swap out my SIM card to one I already had. And the guy said, well, the contacts on the SIM card have all corroded. You've had it more than a year. So I had to remind the guy that, well, those are gold coated contacts. So what do you mean by corroded? And he did not have any kind of a clue that gold is one of the elements that does not oxidize. So that's why we use gold on all of our electrical connections that require high stability, like on circuit boards. When metal ages, it will oxidize and become a poor conductor of electronics or electricity. So that's just a matter of how it works. You know, any type of aluminum, steel, metal, copper, it will oxidize, and when it oxidizes, it becomes a very, very poor conductor because it, when that oxidation process takes place, that produces an oxide, and that oxide is not a good conductor. So stainless steel fasteners don't rust. So that's one of the things that um, stands out as far as something that doesn't rust. To prevent rust, chromium is added to the mix. So chromium is the guy that makes it so it doesn't rust or is less likely to rust. We know that some of the stuff we get from China, even though it says it's stainless steel, it still can have ability to do some rusting, which means they didn't put that much chromium in it. Now, unfortunately, chromium is not a good conductor of electricity. Also, it can make the product you're working with more brittle. It's not as strong as good old steel is. So stainless steel is really good at holding on to two conductors together, holding two conductors together, but itself not a good conductor. So what I mean there is that if you're clamping two electrical conductors together, that clamping mechanism, if you use a stainless steel bolt or strap, that will work very nice because you're not conducting electricity through that bolt or that strap. So just remember that. Like, you know, all my tower stuff. In fact, well, see, all my tower stuff, every bit of that has always been, I shouldn't say always, but it is now completely stainless steel. All the fasteners are up there that are stainless steel. Now, back when I was a younger ham and didn't have quite the funds, I did pick up some used antennas that used regular old zinc coating on the bolts and also on the strapping. And all of that zinc had all disappeared, and those things were just rusty as heck. And most of the bolts I had to break off and break in half in order to get that thing apart. So that didn't work out too well. But if you want something that's going to hold things together and not rust up on you, use stainless steel. That also goes for like antennas that I have up in the trees. I normally anything that goes up through a tree, that's always a steel piece of rope. And these days I've moved everything over to almost everything over to stainless steel. Even those steel ropes that are galvanized, I've had two of those things that have failed that have basically rusted out on the inside. So much for the thought, the use of galvanization, using zinc coating on there to prevent that. So let's see, there's probably not much difference in a signal if you're running a kilowatt. So if you're running a kilowatt, generally you don't worry about too much losses as far as if you have something that's a little corroded up. It's likely to heat up. It may heat up enough where it fixes itself, or it'll heat up and burn up, produce enough heat, and then it'll be pretty obvious to you where you have a problem. Now, if you're using a lower power, like 100 watts or Q or P or something like that, any type of loss in an antenna system can produce a quite noticeable effect on your performance with that antenna. So if you have corroded connections or stuff that wasn't well cleaned when you bolted it together, uh, and you're only running a few watts and you got some losses there, you're going to see it. There is no way of knowing how corroded antenna will inhibit RF radiation. So we always like to think about, in this day and age, we can always put a number to how much you have for a loss, how much you have for a gain. But when it comes to losses and with RF trying to make its way through oxidation, there is no definitive way of doing it. It's just, it's fine if you got some way at the very beginning, you maybe take your nano VNA, put it at a fixed distance from your antenna with your receiver, you write down what that signal strength is and you file it away with a piece of paper. And then maybe a couple of years later, you say, well, something's not working right. And you can get your nano VNA, stick it out in exactly the same place, look at the measurements on the same receiver, and you see, oh, well, that's not, I've lost 3S units there or 2S units. So that means something's the matter, but it doesn't necessarily, then you have to start picking through, well, is it the antenna? Is it the feed system? So that starts another cycle on trying to diagnose what's going on. But generally speaking, it's like, okay, something's changed, but you really don't know what, but there's no nice way of measuring it. We do know that a bad or compromised electrical connection will cause unpredictable problems, especially like RF. When it comes to like aluminum oxide, that can actually make it into somewhat of a rectifier. So that means that when you're throwing some power to that piece of aluminum, you may end up finding the thing produces RF on a different band than what you expect or a different frequency than you expect because of that rectification that's going on from that oxidation there. But in generally, you're just not going to exactly know because it's going to be unpredictable and it really takes a clever guy to end up working your way through and figuring out where the problem is. It's a good idea to take a look at your antenna once in a while. So I don't like hauling my darn tower down and getting my um, beam down here so I can look at it. Now, there's a big difference between looking at it at a distance and looking at it when you're having it right up close. But I do get out my really big high power binoculars and I go through that thing and I look to see if there's any problems, seeing if any place that I can tell that actually, it's not my binoculars. Have a really nice telescope that I get out, and I'll beam that up there and try looking at all the connections and see if I can see any type of rust or accumulation of grit or something that doesn't look right. But it's like going through all the screws, all the fasteners, making sure because I'd like to get it all the way down so I can go through there and check the tightness on everything. Because believe it or not, like that aluminum on some of those um, pipe clamps that go on there, you know, things loosen up after a while. That aluminum actually bends and moves around for you, and you may not have as tight as connection. So it's really nice to get it down and get a screwdriver, get a wrench on it, and go through every single connection on there and make sure that they are still good and tight. If you have a smaller antenna, get it down, get it on the ground, take a look at it and see what's going on. Now, this also goes for like if you got wire antennas up, it's nice to end up getting those things down because you never know where you have connections. I used to always have where I used steel, copper cladded steel, and that is can be a challenge to solder to. It can also be because it wiggles around, but I've had times where that cladding has kind of broken off and I was basically clamping the steel, which is not a particular conductor. And so I've had that for a fault. So get your wire antennas down and look at the connections on that. So here's another good one. So down comes your beam for a quick check. So you think you're just going to pull it down, run through the connections and make sure everything's doing right. So up comes your blood pressure when you see all the little problems. So, you when you really get an eyeball on the stuff, then you can really see the problems. When you can get a wrench on it, then you can see if things are loose and stuff. There's certain ways of connecting feed lines that are not really good, that over time on aluminum especially, you will end up having some problems. So again, it's really nice to get the thing down at eye level to really see the problems and get them fixed. It would seem that cleaning the antenna surface, the better it should perform. So it's nice that you can, a lot of times you'll put up like a aluminum antenna, and on the top of it or on the bottom, especially the bottoms, around if you have any kinds of chokes or any kind of tubing on it that's kind of big, you'll get a bunch of green stuff. So sometimes it's kind of nice just to get it down, get a Scotch-Brite pad and go over the thing and knock all the big clumps and the big green blobs off of the antenna so it can look nice again. Okay, never use steel wool, steel fasteners for conducting RF. They corrode. Excuse me, I started off wrong. So never use steel fasteners, steel bolts, or screws for conducting RF. They corrode. They will corrode, and then you have a resistance problem. Zinc-coated fasteners help reduce it, but I think everybody knows these days that it seems like the zinc coating that we get from all of our Japanese bolt nuts and bolts, they just don't last that long. I have had too much zinc coated stuff up in the air or out in the open where they'll last for about 3, maybe 4 years, and then it's time to replace the stuff. So what's the cost of taking down your antenna to clean all the connections? Stainless steel hardware costs more, but saves in cost of maintenance. So the point here on this target here is that if you got your antenna down, you've gone through a whole lot of work to get it down in the ground, and it's going to take you time to go through everything and make sure they're good and tight, and potentially have to replace some of the hardware because it's rusted on there. If you just start off with stainless steel, it actually keeps your costs down. You're not going to have any rust. You know they're going to be staying good. They're not going to contaminate other pieces of aluminum. It's going to really save you in the long run. So I still highly recommend. Actually, I've been buying bags of nuts and bolts and screws and washers, um, where I have a good box of accumulation. So every once in a while, when I need stuff, rather than just buying, 3 or 4 that I need, I'll buy a whole box of them. I'll buy 50 of them at a time. And then so I have enough over time where when I take something down, I have a good supply to go through everything I have there, replace it with all stainless steel. Get the point? So here's a couple examples. Um, One of these that Chris Craft used to do for their driven element, run the driven element into a piece of tubing, and then you had a jam bolt that would screw down through that tubing and pinch against the aluminum. Aluminum over time, as it moves around and temperature changes, it changes shape and changes form. So that whole process doesn't work after a while. It's a constant problem you have to work with. So one of the things that happens every time you go through there and you kind of jam that bolt down again, screw it in a little further, eventually you're going to poke a hole through that piece of aluminum. Once you poke a hole through that aluminum, game over. You're going to have nothing more than a nightmare. You're going to have a bad connection between that bolt. That bolt is usually where your feet, one half of your feed line is going to connect to. But underneath that, you're going to have problems with not a good connection. So another thing, if you have an antenna like this, you want to put down in that hole there something that mitigates any kind of rust, any kind of corrosion. So you want to put in some or trying to think of the right for it. It's like some no knox or stuff, something that ends up that's a conductive type of grease that'll prevent any type of corrosion there. So the bottom one shows another really persistent thing. Here you have um, steel U-bolts there that are all rusted up. The guy has tried to put tape around the bolts that go through there and pinch the aluminum tubing that goes in there. Well, unfortunately, that kind of tape is going to leak. It's going to let water in there, and it's going to trap water and just do a further job on rusting up the bolts. So that's not really good. So again, bolts should be stainless steel. That whole mechanism in there should all be stainless. So here's a couple other things that as you're looking at your antenna is you want to make sure that your coax has some kind of a drip loop, which means water will run down that coax there, but you don't want the water running into your coax connector or into the nuts and bolts that go into your balun. That black box in the middle there is your balun. There is probably a 4-to-1 balun. So you want to make sure everything has this little loop in there to make sure none of that water gets into that balun. So having said that, um, there's no perfect way of doing a balun. I'll show you a little, show you something a little bit here that shows what can happen with a balun. Okay, good old aluminum. So cleaning aluminum. The left side, you can see where you have the cut marks in aluminum for where it got crimped down onto the piece of aluminum. You have oxidation on the aluminum. Aluminum is one of those kinds of metals that, you know, as soon as it gets poured, as soon as it starts cooling, it starts oxidizing. It builds up a skin on the outside to help protect itself. And that skin can build up, even though you go through there and brush it off and clean it off, it can build up really quickly. Here's another example on how quickly it can happen. So I was welding up some aluminum, and I was using a TIG welder to weld it up. Well, I had gone through there and brushed everything up, cleaned it all up, got rid of all the oxide, because when you're doing TIG welding, you do not want to deal with any kind of oxidization at all because it gets into the weld and it really screws things up. So I brushed it all up, cleaned it all up, and I get the call for dinner. So I go into dinner and then have dinner, watch a little TV. Next morning, I'll go back out. Said, oh, I don't need to clean that thing up. I just did it last night. So crank up the old TIG welder and go through there and light up a nice torque beam onto the thing, get a nice puddle, and sure enough, on top of this puddle of molten aluminum, I have this slag that's floating around on top of it. Well, I know enough that that slag is only going to get into that weld and it's only going to cause me a problem. So I have to shut things down, clean off that oxidation. So in other words, overnight, that piece of aluminum picked up enough oxide to end up building a film that I could find when I turned that aluminum into a molten puddle. So just a point to think about. So when you clean up that aluminum, you need to get something on that that prevents that oxidation. And we'll talk about that in a little bit. So cleaning aluminum. So don't use steel wool. Steel wool pads will leave particles of steel embedded in the darn aluminum. And then next thing you'll have rust spots in there and you'll have problems. Um, the best thing that I've seen is using the Scotch-Brite pads. They're a plastic, but a really, really tough type of plastic, and that does a good job of cleaning up aluminum. And then with a little Dawn dish soap to loosen up the grime and greasy stuff on it, it'll clean it up. So you want to use a little warm water. Just recommend using latex gloves so you don't end up screwing up your hands with the Scotch-Brite because it is pretty pretty abrasive. Use this. You can also use, like on the really tough spots, use a stainless steel brush to get some of the hard cleaning up. Before disassembling any antenna, make absolutely sure that you label all the parts and the tubing. I'm going to back up here, the tubing over on the right. See where someone did a Sharpie around the very top there? And a couple little marks on where the notches is in the receiving aluminum. So make sure everything gets marked as far as the offset distance on how it's supposed to go into it. You also want to make sure that you mark each end of that. So like you have A1 and A2, or if you're going uh, B1 and B2 or whatever kind of marking you want to do. But make sure they're all labeled. So when you get it all apart, get it cleaned up, and you put it back together, you got some idea of what part goes into what. So mentioned about aluminum really oxidizes quickly. So when you get to the point where you get everything cleaned up, um, I've just started using, and it's been an old time thing that a lot of people recommend, cleaning up aluminum with acetone, and that cleans up the most. So see, you've kind of ruffled it up with a little bit of water, with a little bit of abrasiveness, but it still leaves some of that Scotch Brite or some of the aluminum oxide laying around. If you use a clean cloth and a little acetone, and please make sure you wear rubber gloves, latex gloves when you're handling this. Use that to do the final wipe down to get a really sanitary piece of aluminum. Okay, so here's this little secret there to prevent that oxidation. So when you're reassembling everything after you've cleaned it off with that acetone and you let it all dried off, and you also want to make sure you have plenty of fresh air around with that acetone. Use something like Pentrox or Noox or something similar that's a conductive type of grease. That will end up sealing, putting a thin seal on that aluminum and mitigate it from doing any of the oxidation type of stuff. And that's a really good, anytime you have some electrical joint on an antenna product, I really recommend using the Noox or Pentrex to end up sealing that stuff. It really prevents stuff. I mean, I've taken apart antennas that have been up in the air for over 10, 15, actually 15 years almost, taken it apart, and I've been able to take the thing apart with relative ease because the guy put it together using Noox, so nothing got frozen in there. So let's talk about another little friend of ours, good old traps. So traps are guys that make our electrically short antenna elements look a whole lot longer. Really important part. So it allows us to use one element where we can put both 10 meters, 15 meters, and 20 meters on this thing because they're harmonically similar to each other. So one of the things is that you always have holes down on that enclosure for the trap, the big aluminum tube. So that allows all the moisture and the moisture to take and drain out of it. You don't want to have holes up or holes off at 90 degree because that trap container will fill up with water, and all that aluminum wire on the inside of it will oxidize and all short together. So the bad thing about it is that those little holes allow little critters to climb in there. It also allows pollen to get in there. When you get a little moist pollen, what does it allow you to grow? It allows you to grow algae and mold, mainly mold. So those traps that kind of over on the right side have a distinct amount of mold on those things. And that mold, again, it traps moisture and it will short out and it will corrode and it will also short out those trap windings, which is something you don't want. So you have to just periodically take that darn antenna down and pull those trap covers back and go through there and do a clean job. The little picture down in the lower left-hand corner, it looks like someone packed uh, basically a whole lot of grass in there. So we do also have animals that like to end up building really nice nest in there, and they can drag in all kinds of debris. So and obviously you get that kind of debris in there during the summer, you get some moisture in there, that ends up molds and corroding, and then it will end up shorting out your trap. And then you'll figure out, well, gee whiz, 15 meters don't work for me any longer, and you'll wonder why. And that always seems to happen during the middle of winter or in the middle of a contest, and that really messes up your day when that happens. So another thing that happens quite often is that wire that they have that they builds the trap for goes back to some kind of a lug, some kind of a screw, where there it gets connected and gets connected back into your tubing system. And that little piece of wire there and the little bolt that goes in there, if you don't use some no-ox on that, and also when you take it apart, clean it up, clean off all the contamination there, the oxidation, treat with no-ox and screw it back together and make sure it's a tight screw. That's, for some reason, that's a screw that keeps backing out and getting loose. When it backs out and gets loose, it gets to be a dodgy connection. When it gets to be a dodgy connection, it generates heats when you transmit, and then it fails. I mean, I had one tri-bander that used to run a kilowatt into, and it never failed. Right in the middle of a hot contest that I'm just, knocking down QSOs right and left, that thing will just not tune and not work. When I take it apart, burned up trap. So for me personally, I do not like traps, especially on the driven element. But it's also gets a lot more expensive and gets into a lot larger antenna when you don't deal with traps. Another thing to check, and that's the boot that goes on each end of the trap. Um, they're made out of products that over time, Mother Nature and good old ultraviolet will end up causing those things to get very coarse and very tough and very crumbly and then disintegrate. So don't be afraid if you got a failure up there, or that those boots don't look right, or you're going to pull that antenna down and it's been up there for over 5 years. Just as a precaution, buy yourself a set of boots so when you do get it on the ground, you got the stuff to take and fix things. Okay, so here's another one. So here we're talking about basically the upper
Hey,
left.
Mike.
Yeah.
Yeah,
Yes.
before we move away from traps,
Hmm.
are they all serviceable?
Yes. Uh,
Okay.
I'd say all of the current production ones that are built these days are all serviceable. Yes.
But I'm just recalling I've got an antenna I bought secondhand that I haven't put up yet. It's a Mosley 32A, and I'm thinking it's trapped. It's only a
Hmm.
2 element, but I'm thinking the traps didn't look very serviceable. It looked like I'd break them if I opened them, kind of thing.
Well, it may be old enough. I'm familiar with other Mosley stuff, the more current stuff, and I know that that is a pliable boot that sits on the end.
Okay.
And when you take off the tubing clamp there, you can slide that boot off, and then
Okay.
you can slide the cylinder that enclosed the trap. You can slide that off.
Okay. I'll take a look at it.
Yeah.
All right.
But
Thanks.
good point. Yeah, because I had an oldie there that the trap sizes were not standard. I mean, nowadays, all of the that outside tubing is pretty standard as far as I think it's 2 or 2 1/4, something like that. So it's pretty easy to find boots for it.
Okay. And it just I know it's a little off subject, but we call it a trap, and then you call some, other times you're calling them coils. Is it a trap because it's a type of coil in the way it's used, or is it a trap because, like you mentioned, aluminum wire versus something else wound on a coil?
Okay, so that is built up as a inductor capacitor. The wire in there makes the things look longer, like it has an inductor in series with that element. So it
Hmm.
electrically makes that thing longer. That tubing, that aluminum tubing that goes on the outside also adds the capacitance in there to nullify some of the inductance so you don't get a bunch of reactants. It'll make it tune correctly. So that thing is a tuned circuit with that outside shield up there for capacitance.
Okay, thanks.
Okay. Okay, so that upper left-hand corner there, good old piece of aluminum, looked like someone was using some type of a tubing clamp that was um, I'm guessing it was probably galvanized with zinc, but over time it rusted. So all that brown stuff is steel oxide, and that has permeated the aluminum there. What it means is you got to end up getting rid of all that brown stuff there. So that can be pretty tough. You're probably going to have to get a wire brush or a wire brush that fits on maybe the end of a drill and get in there and really go at it, or take some sandpaper and make a loop out of it and take and grind some of that off. But it's going to take some work to get that off there, because if you leave that there, that rust only permeates and moves around and gets larger again after it gets wet. The other time, sometimes like the one there in the lower right hand corner, um, you can see that, oh, actually both in lower. Sometimes it leaves some marks there so you know where to, the next time when you go through there and replace all those U-bolts, you know where things need to line up again when you get things cleaned up. But that stuff still needs to get cleaned off. You know, it should hopefully leave a little mark. Sometimes you need to get a black marker in there and take and mark it so you don't lose track what's going on. But those are tough ones to get out. They got to go. Okay, hardware does not improve over time. Anything you put out in the air, it will all start disintegrating or going bad as soon as you stick it out there. But the more that you put into it, as far as preventing those types of corrosion, makes things last a whole lot longer. So the boots on the traps, that's all stuff that can be replaced. Make sure you have some kind of a cover on each one of the ends of each one of the elements and each one of them mast. If they get worn or chipped or faded, replace the darn things. Get get replacements there, and make sure that whatever you replace it with has a high rating of resisting ultraviolet. And if you do it right, good insurance means you won't have to worry about taking it down the next time. So here's the inside of a ballon. Now this ballon has only been up for 3 years. Generally on ballons, on the lowest part of that ballon, you usually have a little hole in there called a weep hole. That weep hole will make sure that any kind of moisture that gets in there has an avenue to take and drip out. The downside of having that frickin' weep hole is that it's a nice place for critters to hide. And you can see after 3 years, this one ballon, it attracted a whole lot of critters, and they had a very uh, nice place to get out of the elements up there. And you can see what it looks like. It's a real
Couldn't
mess.
you put a small bit of mesh or netting or screen or something in that weep hole to prevent the critters from crawling up through? Still let
That's
water out?
glad you brought that up. That's one of the things I bought some mesh. It's stainless steel. It's for straining, like for foods, for straining out particles, um, like for if you're making jam or something like that. Normally we'd use that with some kind of a cloth to do that in the house, but
Like a cheesecloth kind of thing.
like a cheesecloth. But this is stainless steel, and you can get it with different gradations in there. And I've been taking some of that on occasion. If I have some real problems, I'll drill a bigger hole and I'll take that and make a little cup and glue that in place there. So those openings are small enough where bugs ain't going to get through it, but it allows air to move through that and dry things out.
Are you still in the trial phase, or have you actually had any success yet?
I haven't pulled anything down yet, so it's only
Cool.
been a couple years, but I haven't had anything down to pull apart. But yeah, good point. Thank you for bringing that one up. I forgot that I do that. But and you can find that kind of mesh on Amazon. It's not you don't need a big piece. I mean, you're going to buy a piece that's 10 times larger than what you want, but it's still like a 2 foot piece that you only need a little corner out of it for each one of your balance. I thank you for that. Okay, another one that we always forget, and that's our grounding rod out there. So many times we just take a wire, stick underneath a clamp, and clamp it down. Well, there's a little bit more to it than that. You want to make sure that the inside of the surface of that clamp has been cleaned off and is showing nice and bright, shiny brass. You also want to make sure that the surface that you're clamping to is nice, bright, and shiny copper on there. Now, be aware that most all these darn pipes that we put in there, all it has is a very fine coating of copper on the outside. So you can't get in there and be abrasive with a piece of file. You need a little emery cloth or a little something very fine to clean off whatever kind of oxide it is to get a decent surface. Hit it with a little acetone. Take some no-ox. Make sure you paste up everything you can with no-ox and then clamp it down. But also come back to that every once in a while. Check those darn bolts on there to make sure that they're still good and tight. Because you don't want to lose ground. That'll drive you crazy. So another one, like if you're doing something on a car.
Hey, Mike, on the
Yeah,
last one.
yeah, Joe.
Yeah. I remember somebody saying there was a way you could. There, it was a long time ago. It was like I can't remember the details, but you had a way of bonding the
Yep.
ground rod. So this is what I'm familiar with, what you're showing in this picture. But there was a way of like fusing with this solid. You like had to light it with like a almost like a butane torch or something to get them to ignite, and then they fuse together. Do you know what I'm talking about?
Yeah, cadmium. It's a product like they use on when they're building towers. So when they want to bond a string of copper with another string of copper, they have this little clamp or this mold that goes around it. They fill it up with cadmium. They light it off with a little torch, and then it goes and does a bunch of sparkly stuff, and it leaves behind a copper bond where things are actually fused together, welded together. And so that is a bond that is not ever going to oxidize. It will stay there for the rest of its natural life. So that's a really cool product. Um, Not everybody's going to want the expensive of all the little casts that go with it and the expense of using that product to take and do maybe this kind of bonding. Now, if you're putting up a big major tower was that was really more commercial and you were having to deal with real lightning and stuff like that, then in that case, you probably want to do that.
Okay.
Is,
Yeah. Would it even work in this application in this photo? Because of, most ground rods, like I know the one I drove down was copper clad on the outside and whoever was steel on the inside. Um, that little bitty thin, how many thousandths copper, would you just melt it away and you'd lose your investment.
That's what I would be concerned about. So I would say that research needs to be done to see if it's really applicable to using a copper clad ground rod. I
Okay.
don't know because I would be very concerned like you were that that kind of heat being induced there is going to end up basically peeling off the copper.
Okay. Okay. Thanks.
Okay. Yep. Feel free to throw in questions or other observations or other ways of doing things. But okay, a little bit about bonding on automobiles. Um, so virtually everything metal on it, like if you're trying to bond the hood, the trunk, the car doors, whatever panels are on there that just you want to make sure is all one continuous piece of ground, and not, you don't have some piece of ground that's floating that's re-radiating some RFI that the engine is taking and creating for you. So when you know, obviously the one over on the left there, that's pretty grungy there. You don't know what he's connected to. One over the right, you can tell that the guy went through there, and you get in there with a wire brush or um, an electric drill that has you know, one of those gnarly brushes on the end of it, and you strip away that paint, the rust, and everything that's in there. You get it down to good, clean metal. You go through there, hit it with some no ox on there, some to prevent any kind of future oxidation, and then you put in some good stainless steel hardware to make that physical connection there. Okay, grounding. Let's see. Clean all surface before assembly. Make sure you use a conductive lube like Pentrex or No-Ox to prevent oxidation. Big takeaways there. Okay, let me get through this real quickly here. So check conduct connections on feed points. This is for wire antennas. I kind of already went through this. I moved off to using stainless steel rope because I've just had too many failures. You put up, plastic rope, it's going to stay up for about a year before the squirrels or ultraviolet gets to it and just rots it away. Um, Coax, typical failures for coax is water intrusion, cause corrosion inside the coax. All the braiding in there gets all corroded up and doesn't do what it's supposed to do for providing the shielding. High voltage shorts also ends up happening. Just because you use coax seal or rescue tape for sealing the end doesn't always mean that you have a perfect seal to keep all the water out. So just because you can tout that I put some of this rescue tape on there, it's self-vulcanizing, doesn't guarantee that you're going to keep all that water out. And also coax doesn't last forever. Um, okay. So yeah, if you're putting any kind of a connector on and you see any kind of discoloration in that, just keep cutting back until you get good clean coax and you don't have any intrusion from water. So here's kind of the last bit of information that I'll hit on. That's rotators. Rotators have gotten very, very expensive. Means that high gain and all the other guys that have produced this type of rotator, parts are no longer being produced from it. Parts also have gotten pretty much exhausted. That stupid little resistor on the very top that tells you what direction the rotator is pointing. It used to be 12 bucks, then it went to 25, and then then it started getting kind of hard to get from MFJ when MFJ bought out I think high gain for that, and then it went to 50 bucks. Well, now those things are well over 100 if you can even get them. They are not being manufactured, and it is really, really tough to find it. The gears that on the inside you can't get anymore. So one of the things you want to do is really, really protect the thing. And the point of this discussion is here, The bottom of that rotator is where you always have the wires come in. You have a bunch of screws in that. You have a plug, some kind of connector in it these days. But once you end up figuring out what kind of connector you want to use in there, be very careful on protecting that thing to keep the water and contamination out of it because it's at the bottom of the rotator. All the water wicks around the outside of that rotator casting and ends up right on that connector. So whatever you can do to protect it, it's worth your time because these rotators like this that we've been using for years as hams, they're a vanishing species. They're going to disappear. Um, I guess a couple things that you probably, if you haven't taken one of these rotators apart, the first thing that you do is you put them on a box and you pull the the four bolts out of the bottom of it, and then you have bearings that splatter all over everywhere. If you don't put it in a box, those bearings go on the floor, and you'll never find you'll always miss one. You'll never find one that you're missing that you need to put everything back together. Plus, they get all filthy dirty. Um, if you take one apart, it used to be you always replace that rheostat at the very top because that's the first thing that goes out, and that's just one that wears out and it'll cause you grief. And you really don't want to have to take down your tower, pop off the your drive mast just to get your rotator out, just to replace that stupid little rotator or that rheostat in there. Just one of the things you just do. So if you want to buy stock or have want to make some income, search around and see if you can find any of these old rotators. The parts out of those things are priceless these days. If you have your rotator apart, check the bearings, raceways, any type of rings. Make sure you clean them up, re-grease them, look for any worn parts, replace them as you can. I know guys can take them all day to pull one apart and rebuild it and put it back together. I don't know what I'm missing, but I can take one of those things, pull apart, clean up all the bearings, check out raceways, re-grease all the gears, and replace that rotator or that rheostat at the very top and have it back together in 2 hours. So I just don't know what guys are doing as far as taking all day looking at all the neat little parts in there. It doesn't take that much time, but it's well worth it whenever you get your tower down to end up spending some TLC on it. So let's wrap things up. Any device that lives outside will weather and corrode, guaranteed. Unless it's made out of solid gold, it's going to end up rusting. For your antenna, tower, and rotators and grounding systems to function properly, these devices require maintenance. Just don't expect put them up there, run them till they die. You're better off just pulling them down every once in a while, doing some maintenance on it, and you need to do that really about annually to make that work right. So if you don't maintain the device, it will fail, and at a random time in the most unpredictable and most inconvenient time when it fails. Give your antenna system some attention. It will work hard for you. Excuse me. So that's it, guys. So any comments or anything that you might have on it?
Yeah, Mike, great presentation as usual. I just a couple weeks ago I took apart at LC we have a Invis antenna. I took that down just to do maintenance on. Actually, what happened was I had a piece of window line that went up to the ballon up at about 25 feet from a remote tuner, and that the window line just came down by itself. So I knew something was bad. So I took the whole thing down, and sure enough, everything was corroded beyond recognition. I mean, all the metal steel parts. Sorry, the hardware. So I just did exactly what you said. Went out and got all the stainless steel, which is a little bit more money, but not that much more. I mean, and then replaced all that. And originally those, all the screws and nuts and all that stuff were bought at probably Home Depot, galvanized, and they don't have the best, parts for that kind of stuff. So I would always rely on stainless steel,
Yep.
you know.
Well,
And
Yeah, one other thing on stainless steel. Stainless steel has, like I mentioned, has chromium in there. That's a very, very brittle product. And when they're spinning and putting the threads on that, they're spinning in one direction. And so there's little pieces of chromium because it's kind of bent, will stick up in those threads, both for the nuts and for the bolts. So when you put those things on there, fine, you're going in the direction that it likes as far as putting it on there. But when you try taking off, it can be a problem. So it helps to treat every single one of those with some anti-seize, and that'll make taking that thing apart a lot easier.
Good. That's the other part of it. Yeah. Yeah. I have a product that has copper,
Yep.
like a micro, particulate copper in it. And I got it when we were putting up some butternut antennas, and that was the recommendation from the company. And so I think that stuff's great.
That
That's,
is true. I think that is really more crafted towards higher temperature things.
oh, okay.
And so I'm not saying that I mean, it's still good stuff. You can use it in whatever temperature you want to, but if you have like stuff that you're like on a manifold or something like that, that is going to get pretty darn hot, you
Okay.
can put it on those bolts, and that will provide a little bit of copper cladding that goes on as that heats up and the copper comes out of solution there, and then gives you a little better opportunity to get that bolt back off of there after you've used it for a while.
Well, good point.
Yep. A little too much metallurgy there.
Oh, it's good to know.
Any,
Mike,
anybody
Mike,
else
this
have
was
any?
great. I think you should retitle this "The Devil's in the Details." Um,
Yeah.
really, because I mean, we're talking about small components that have failed at the weakest link under either weather, stress, or even just metallic, um, interactions. And
Yep.
um, and so it's just a great reminder that you can look at the shiny wire of an antenna and go, wow, it's going to be perfect for my contesting weekend. And you put your analyze on her and go, it's probably some bad coax. Um, Let me swap that out. And then you just keep going with it, not knowing that it's a little tiny screw that come loose from, you know, uh,
Mhm.
an aluminum rod somewhere in the innards of an antenna system or the grounding system, like you pointed out.
So something that I have never ever been able to figure out, but there's some little gremlin that comes around inside my shack here and loosens up my coax cable. And then I start getting a stupid, weird SWR. I start tracking things down, and I find that the coax on the back of an amp or something is basic, or back of a filter is loosened up. And you just never know where and what's going to happen. It's like when you put stuff up in the air, you have to make sure you do it right. And when you and if you do it right, you don't have to keep taking the thing down to screw around
Yeah,
with the thing.
yeah. So two things that I'm aware of that I've seen firsthand is heat and vibration. And I've seen some folks in my old PA club, what they would do, I'd go in their shack and I'm like, why did you put this coax seal on the back of your radio? And it's like, I don't want that connector moving.
That's right. Yeah. Yeah. So I have a little crescent, little wrench that I use, that set of pliers that I go through there. And once I get it screwed down finger tight, I give it a little assistance anymore to
Yeah.
make sure it stays tight. Anything else, anybody? Scott, did you have something there?
Yeah, sorry, I was muted. Um, with the self-vulcanizing tape
Mm-hmm.
and the silicone tape, um, I know that water can still get in. What is the best? I mean, if when you're putting up your say your Yegi's up on the top of the tower, and you want to, I mean, is it sufficient just to do the wind that self-vulcanizing tape on there and hope that it will stay waterproof, or 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 are we inevitably going to have water intrusion?
Okay. Good question. So I'm not sure this is a perfect solution, but I have had very good luck with provided you can get that self-vulcanizing tape far enough on the threads of the 250 or the male part of the 259 that comes out of the balun, and that's trying to get something up close enough and enough threads because those threads up at that end is what's going to let the water intrusion. The tape itself, I haven't seen any fault in that as long as you keep it smooth and you don't have lumps in that, you don't have folds in it. You keep it a good smooth where everything's stretched out nice. I have never seen water get past a seam in that self-vulcanizing
Yeah,
tape.
yeah, I
So
agree.
and same way when you get off of the 259, you want to go at least a couple inches, 2 or 3 inches down the coax with that tape to make sure that nothing gets wicked back up there
Yeah,
on the inside of it.
yeah, I've been pretty impressed with it because I have for instance, a J pole up on the roof, and I use that tape at the at the connection point, and it's really held out. I mean, that joint does not get water intrusion.
Mm.
And I go up every year to inspect, and after the winter of like what we're getting right now, it holds up very nicely.
And
So,
when I first started using that, the other thing I used to do was then go through there and protect it because that's a soft ductile type of tape. Used to take electrical tape and good quality electrical tape and then wrap around on top of that.
oh, that's a good idea. Yeah.
I'm not sure if it's a good idea or bad idea because you will get water underneath it, but it's not going to get through the safety tape there.
Mm.
But and I don't, I have, I've used the black and the red tape. I haven't used the green tape, so I don't know if there's any difference in ultraviolet intrusion that would harden the tape or cause a failure in that area. But uh, So, you throw in the electrical tape on there. I know that's ultraviolet safe. I don't know if it's going to survive how many multiple years it's going to survive, but just
Yeah,
another.
probably once a year is the best thing to do is just redo everything when it comes to that, if you can.
Anything else, guys?